We're going to talk now about layer 3 routing on NXOS-based devices and where it's supported and where it's not, what licensing we need. Again, I'm not going to get too deep into all the routing protocols. This isn't a route switch test, but we will explain the different protocols that are supported within the systems. And if you want to come take the lab prep boot camp, then I'll send your mind spinning in several different ways on how we do the routing with these specific protocols. What we're going to see is that there's a lot of routing support on these different platforms. The 5548 and the 5596 both support routing, but like I mentioned earlier in the introduction, only with the presence of a layer 3 gem card. Okay, so we have to have the 55 with the gem card, or in the scope of the lab, we have to have the 7K with the M series modules. Okay, some of the newer F series cards do have the ability to route, but the F1 cards have to rely on proxy routing, basically through the presence of an M card in the system or within the same VDC. Okay, they support static routing. They support RIP version 2. Notice no support for RIP version 1 in there. We support OSPF, EIGRP, BGP, and IS to IS on the 7K. We will also see on the 7K they support Lisp. Okay, so we do have the ability to do the locator. Oh my goodness, I wasn't going to say the name, but then I started. But they have the ability to support Lisp in the different Lisp environments. Now, Lisp is a little bit different. Some people don't really consider it a routing protocol, but if you're doing, layer 2 extension technologies like OTV, Lisp does come in handy to be able to advertise certain prefixes in maybe which data center or which location they are actually in. It's like the locator identity separation protocol. So they take the location away from the identity, if I remember correctly, and it's really, the location. This identity could be at location A or it could be at location B. Really doesn't matter. The Lisp infrastructure will keep track of where that specific guy is within your network. Okay, so we have quite a bit of support there, both on the IPv4 side and the IPv6 side. But again, you need certain licensing to be able to run these protocols. What you'll see is that typically with the Nexus 7K device, what we're gonna have is both static routing and RIP version 2 routing with the base system license. All right. If you go out and you get the enterprise services licenses, that's when you're going to get the IS to IS, the BGP, the OSPF, and the EIGRP. All right. That's when you're really going to get the full routing support, is when you have that enterprise services license. The Nexus 5K will support RIP version 2, EIGRP stub routing, OSPF up to a certain extent, HSRP, VERP, and everything else with the base license. But if you do want all the other protocol support, including full EIGRP support, you're going to have to go out and get the LAN Enterprise Plus license on the 5K. And again, remember that you have to have the GEM card, the Layer 3 daughter card, if you do want to run Layer 3 services on the 5Ks. We do have support inherently for bidirectional forwarding detection, which is really, instead of going in and having to manipulate all of the timers of the specific routing protocol, say you wanted OSPF to converge and send hellos out maybe every 5 seconds and failover within 30, you could go out there and modify all your nodes within OSPF with these adjusted timer values, or you could just configure BFD and register the protocol with BFD. BFD stands for bidirectional forwarding detection, and what it's going to do for you is it's going to allow you to send these small little hello packets out on the link, and we're going to do this at a default of 50 milliseconds. At 3 missed frames or packets, what will happen is we'll detect the failover on that link. BFD will inform the routing process that it's lost a neighbor on that link, and will allow us to go ahead and drop it down and converge the topology. So again, BFD gives us basically a central point of timer management, so we can point our protocols to BFD, and BFD will determine whether the neighbor's up or down. So again, we can have sub-second convergence for all our protocols when we register them with or the interface with BFD. Okay. Like we mentioned earlier, a lot of these different protocols will allow us to do graceful restart. We can see that it's on by default on the NXOS platform for some of these different protocols, and will allow the neighbor to restart that process without actually having to kill the data path. So we can restart the control plane while keeping the data path up and running. We'll do that through the use of timers, and like we saw with OSPF type 9 LSAs, okay? EIGRP, if you guys have messed with EIGRP really at all, it hasn't changed, okay? We're still going to go in and it's still just normal EIGRP. It's still going to run on IP protocol 88. We're going to send, so it's IP 88. We're going to send our hellos out on 224.0.0.10. We have the ability to do passive interfaces where we insert interfaces into the protocol natively, but we don't support maybe the forming of any neighbor adjacencies off of that interface, okay? We could still do summary addresses at an interface level, which is really one of my favorite features of EIGRP is the ability to go into a specific interface and shoot a summary address out that interface towards our neighbors. Again, we'd have to have at least a portion of that summary within our local tables, but we have the ability to summarize it at interface level. All right, just awesome. It does still use the diffusing update algorithm, so it will build it and run the dual algorithm to find the best path from A to B. We have the ability to support equal cost multipass, and it defaults to 8 different equal cost multipass by default. Some of the big differences between how we really come in and turn up EIGRP on NXOS versus iOS is that traditionally in iOS, you know, we would come in and we'd give the old router EIGRP, and then we'd give some numerical value. And this numerical value would be our autonomous system value. Okay, so this would be, you know, if we're going to form adjacencies with a neighbor, we need to all be in the same autonomous system. So we would come in, configure the routing process and the AS, and then we might come in and blast the no auto summary command. This would stop the auto summarization of major networks at a major network boundary. So we don't have to run this command. There is no automatic summarization that's going to be done in NXOS by default. So that's the real first difference between iOS and NXOS that you guys might actually recognize. The next thing we would do, at least the next thing that I would do, is I would come in and start typing my network commands. Okay, this is where we put our interfaces into the routing process. So I might come in and say, you know what, network XXXX, and then I'd put in a subnet, you know, Y. And for me personally, what I would do with this subnet value is I like to come in and just put a specific interface in there. So I might come in and put, you know, network 192.168.1.1, and then my mask would just be 0000, and that would just put that specific network, that specific interface into the routing process. So rather than trying to cover up like a whole subnet with that statement, I always went on an interface by interface basis and kind of picked those out. And that's just the way that I always did it. What they did with NXOS is a little bit different in that we come in now and we place the interface directly into the process. So we might come in and create a process called, you know what, router EIGRP CCIE DC, which is one of the first main differences with the configuration, because now we can do a named process in NXOS. But if we do a named process, you got to kind of watch out, right? Because now we don't have what declared? The autonomous system. So we have to come under these guys and declare our autonomous system if we use a named process, and maybe use like 100, okay? That's really all we have to do under the process in NXOS from a default standpoint. Everything after that, we might come down here under, you know, interface VLAN 10, and we might say IP router EIGRP CCIE DC. Okay? At that point, that specific interface, again, not, you know, we're not covering up and saying, you know, everything that falls in 192.168/16 is in the process. We're saying this interface and the subnet associated with this interface is in the process. Okay? Nothing more, nothing less. And again, along as our basic EIGRP properties match, so we have the same subnet, we have the same autonomous system, we have the same K values, we'll form an adjacency with the other end, okay? We'll see that we also have different route updates with the EIGRP. And again, this is all fairly standard, right? We have the internal routes that occur, routes between neighbors within the same AS. We have our external routes, and then something that's new to NXOS is the ability to use these wide 64-bit metrics. So what previously it was these 32-bit metrics. What they've done with NXOS is given us the ability to use 64-bit metrics to, again, provide more granular route selection. So essentially we're going to use a separate K value rather than 5. We're now going to use 6. But we can use essentially more metrics to kind of dictate, okay, this is a better path than this path. And a lot like spanning tree and what we're going to see with the path cost method, the wide routing metrics will allow us, again, more granular route selection because now we have larger links and more link speeds that we need to determine here. So the 64-bit metrics really allow us to take advantage of some of those. The configuration, I kind of just included a little snippet here. This is just how we'd go through a basic EIGRP config. We turn on the feature. Again, always remember the feature, okay? Once we got that enabled, we'd enable the process. So this would be our actual route process. And then we could come into an interface and turn it on. They did forget something here, though. What did they forget? Which we just discussed. We have to have an autonomous system. So we'd have to come in here and actually place the autonomous system and the number value directly into this process. So we'd have to declare what is the autonomous system that we have to use, and then we could place the interface into the process. All right, so that's how we'd go, again, from a greenfield stance to really get the EIGRP instance up and running. And again, we can still have multiple EIGRP instances within the same device. So we could have, this VRF using this AS, we could have another VRF using this AS, we could have the same VRF using multiple instances, okay? So we could have the default VRF, and we could have a CCIE DC1 using AS200, and then we could have CCIE DC2 using 250, okay? So we still do have that ability to kind of juggle those, and then we can still redistribute between them all. OSPF, again, OSPF is industry standard in typical multi-vendor fashion. What we're going to see is that OSPF is still the same old OSPF. We still have, rather than autonomous systems, with OSPF we're going to be using areas. So if you guys have studied OSPF in the past, maybe for the route switch, maybe for the CCNP exam, we all know that if we want inter-area OSPF, if we want multi-area OSPF, we always have to traverse what we call the super backbone, right? And we have to, that's area 0, okay? So if we had a router up here, and then a router down here, and another router down here, and this guy hosted, area 1, and this guy hosted area 2, this, between these guys, would have to be area 0, right? We cannot do inter-area OSPF without first traversing area 0 first. And again, you guys are probably looking at me cross and going, oh, we can use virtual links, and we can slap this in here and this in here. Right, but this again is not the route switch exam. This is the CCIE Data Center exam. So we need to come in and know how to configure. And guys, I'm not lying. If you read the blueprint, we need to know how to configure OSPF at a basic level. All right, and basic to me is really getting the process up and running, getting the interfaces introduced into the area, maybe doing some authentication or some route summarization. But anything beyond that, like if you cross into the virtual links and all that, that's more advanced OSPF that we don't necessarily have to deal with. We're also going to see that we're really only messing with OSPF version 2 within the scope of the CCIE Data Center Lab right now. So we're not going to be messing with OSPF for IP version 6 or what we know as OSPF version 3. We will see that this entire system is going to be based off the RFC 2328. So we're not going to be able to use any older or anything that's compliant by RFC 1583. Okay, so we're strict, again, data center class operating systems, so they're only going to support data center class protocols. So we're going to see OSPF based on RFC 2328. Again, a lot of this is hubbub that you guys really don't need to worry about. But OSPF in general is going to be configured the same way as we saw with EIGRP, where we're going to turn up a process and then we're going to place interfaces directly into that process. So we might come in and enable the feature OSPF, introduce the OSPF interface into the area. And in this example, they didn't even go in and configure the actual OSPF area. So we would also want to come in and just configure the router OSPF 201, for instance, and again, really that's all you have to do, because after that you're going to be placing the interfaces directly into the process itself. We still could come in and have to insert in maybe a static router ID. What you'll see is that by default within NXOS, no matter what protocol you're using, NXOS is always going to choose loopback 0 as the router ID if it's available to the system. If not, it's going to choose the highest loopback and then the first available physical interface that it comes across. So a little counterintuitive than what we saw on a lot of iOS-based devices where they'd always take the highest loopback. What we see with NXOS is that it always takes loop 0 by default. So if loop 0 is there, no matter if it's the highest IP loopback or not, it's always going to be the one that we choose by default. So we still do have that ability to go in and statically configure the router ID that we want to use. If not, you're just going to leave it up to chance, and it's going to peel through and basically take it based on that selection criteria that I kind of just explained. Now, OSPF and EIGRP, guys, are the only ones that are supported, or actually, sorry, tested on within the data center lab exam. The written exam is going to ask you, or you have the possibility of having questions about any of these different protocols. But know that when you step into the lab, again, they only ask you to configure basic OSPF and basic EIGRP. Beyond that, I mean, when you really look at anything layer 3 wise, you're talking maybe bidirectional forwarding detection, and then HSRP, VRRP, and GLBP, okay? Those are the entire scope of layer 3 protocol within the CCIE Data Center Lab Blueprint. So again, we may be asked questions about some of these other protocols, but once you step into lab prep, this is all you have to worry about. And I don't know about you guys, but that's a glorious thing, okay? OSPF, like you guys saw, is still OSPF. It's been simplified extremely within NXOS as well, because NXOS is a true Ethernet-based switch, so we don't have to deal with any of those really weird network types anymore. So with OSPF, we only have the point-to-point and the broadcast network type. So all that point to multi-point and all that garbage that we had to deal with traditionally with like frame relay has really been tossed out the window. Okay, we only have the 2 network types, and we should know, if we've done any routing before, what the differences between those 2 are, right? Because on the broadcast network type, we have a DR and a BDR election. On the point-to-point, we're only connected to one other router, so we don't have that DR-BDR election. So again, things have been greatly simplified with the NXOS-based platform, and then it's simplified even further in that we only really need to know about OSPF and EIGRP in terms of configuration on the lab exam. But again, BGP is supported. We support BGP version 4. This includes a lot of the multi-protocol extensions, so if you want to do like BGP and MPLS VPNs, we do have the ability to do that. We do also have the ability to use layer 3 address families. So you guys, if you come from a strong CCIE route switch background, you massaged some BGP in your past. So we do have the ability to do full-blown BGP, though most of the time, and I'll actually step out on a ledge here and say, I've never configured BGP in a production environment all the way down to the 7K. It's always, you know, if people have the money to throw in a big Nexus 7K data center and 5Ks, 2Ks, it's always been like ASRs at the edge or something like that running the BGP. So traditionally I've stuck with IGPs, But again, we do have the ability to support full-blown BGP. I just threw some blurbs in here that you guys can read through that uses a path vector algorithm to exchange routing information. Just, again, a lot of jargon in and around BGP. If you guys have messed with BGP, it is one of the most flexible protocols that we can actually go out there and use. But again, it's not going to be widely adopted on the Nexus platform because typically people aren't going to extend their WAN infrastructure all the way down to their 7K. Some of you guys may be different. Some of you guys may be running BGP on your 7Ks right now and be going, yeah, you're crazy. But again, I, from a production standpoint, have never pushed it all the way down. The configuration, again, is going to be very similar to what you guys saw anywhere else. We're going to configure the BGP process. So we're going to declare the, once again, the autonomous system number that we're going to use for BGP. We're going to introduce it into either an IPv4 or a VRF unicast routing table. And then we're just going to start placing our networks into that process. So again, not a great deal of configuration. It's very similar to anything you guys have seen before. We'd have the ability to use route maps. We'd have the ability to do AS path prepending, so on and so forth using BGP communities. So BGP is BGP. We do have the ability to run it on the Nexus platform. We will also see, and one of the most highly anticipated topics within the data center realm right now is jumbo frames on these Nexus devices. So, I kind of stepped back and was like, I'm just going to write a couple slides here to explain, how we manage jumbo frames on these mainly 3 different platforms. So I'm going to be talking about the 7K, we'll talk about the 5K, and then we'll talk about the MDS. So on the 7K, guys, it differs, okay? So we have, layer 2 and we have layer 3. So let me tell you this. By default on here, within the 7K and the admin or default VDC, there is a command called system jumbo MTU. It is by default set to 9216 bytes, which is as high as it can go. All right. So this is the system default. Now every layer 2 interface is using the default MTU of 1500 bytes. So if you have a layer 2 interface, it defaults to 1500 bytes. So what we can do with the layer 2 interfaces, it can either be this value or it can be this value. It cannot be anything else. So you could come into an interface like, interface Ethernet 1.1 and say this was a trunk. You could come in here and specify MTU, and if these were our defaults, okay? Right now, we could either be 1500 or 9216, okay? Because 9216 is our jumbo MTU. If we tried to type anything else in there, we would get an error, okay? If we change this, so say we came in and said, you know what, our jumbo MTU is going to be 9100, then we'd be able to either type in 1500, which is the default, or 9100. You guys get where I'm going with this? This number has to match whatever is declared in the jumbo MTU. It can be one or the other, guys. It can be the default or it can be the jumbo, but it can be nothing in between. So the only number we can really modify, right, is the system jumbo MTU. For a layer 3 interface, it's a little bit different, okay? So if you have a layer 3 interface like a SVI, we could come into, interface VLAN 100, and we could really declare anything that we wanted to. So we could come in here and say, you know what, MTU is going to be 9070, all right? So for the layer 3 interface, we absolutely have to go in there and increase it though. So we could come in and declare the MTU under the layer 3 interface, and it'll be good to go. The layer 2 interface is a little bit different. We can only really be the default or whatever set as the system jumbo MTU, all right? Now, the Nexus 5K platform is a little bit different, and the kind of configuration, if you've never done it before, is a little convoluted, but you have to modify the default jumbo or the default network QoS policy. So typically what I do is I go in there and I'll do a show policy map type network. Whoops, ran out of space. Network QoS. It'll go ahead and print it out. So I'll go ahead and just take one of the default network QoS policies, I'll paste it into Notepad, and under my class default, I'll go ahead and just bump up the MTU to whatever I want it to be. So 92.16, whatever your upper bound's going to be. Go ahead and set it in there, and then all you have to do is go into your system QoS and apply the new policy. So you'd go in there with your service policy command, and of course it would be a type network QoS, and then your new policy name. All right. Once you type that in, you would now be supporting, whatever increased MTU size. We're calling it the jumbo MTU here, so if you set it to 92.16, you would be supporting jumbo MTUs on this platform. Again, if you're using a layer 3 interface, you still have to go in and set that. All right, so if you're using an interface VLAN, you still need to go into the interface VLAN, X, and set your MTU size to 92.16. But if it's a layer 2 interface, it's automatically going to begin using this new system MTU for the class default. All right, so if you go in there now and you say show queuing interface, you're going to see that the class default queue or anything with the cause of 0 is grabbing within that class default. So anything that's not matched within the policy is now going to be using the MTU of 92.16. All right, if you add any classes to this policy, remember that you need to bump up the MTU in those guys as well. The last one is the MDS switch, and it's probably the easiest one to really go in and modify. You just need to go into the interface itself, okay, and adjust the switch port MTU. So you're just going to run the command switch port MTU and maybe increase this to 9100 or 9216 or whatever you want to. But this is only going to be done under the gig interfaces, all right? You won't be able to run this command on any of the fiber channel interfaces. So this is strictly a command, the switch port MTU, that's applicable to the gigabit Ethernet interfaces on the MDS itself, all right?